Good morning. So today what we're going to do is talk about the second part to the ellipse that we didn't finish up the other day. And I'm going to teach you through the video. What I want you to do is pause the video when I give you certain problems. Try to do it on your own in your notebook. And then obviously you can replay the video so I can walk you through the steps and see where you went wrong and kind of teach you how to do the rest of it. But try your best, okay? So bear with me. This is new for all of us. So we're going to start with a warm-up, and the warm-up is this right here. And just by looking at it, I know that it's a parabola because I notice that only one term is being squared, right? So let's look at my paper. So what I want to do first is always try to get rid of the fraction down in front, right? Make your life easier. So we know that there's 1/4. We're going to go ahead and multiply the entire equation by 4 so that we can get rid of that 1/4, right? So I just kind of like loop it. We've got 4y is equal to x squared minus 2x plus 5. Now, we know that we have to complete the square, right? Sorry, I'm trying to like figure out this camera thing. So we know that we have to complete the square. And the way you do that, obviously, is by taking your b value, dividing that by 2, and squaring it. So we've got x squared minus 2x. We have 2 divided by 2, and squaring that, we've got plus 1. Now remember, we added and subtracted on the same side of the equal sign, bringing down that c value. So we have to go ahead and factor the first 3. Remember, it's supposed to be a perfect square trinomial, and it is. We've got x minus 1 squared, and then adding your constants together over here. So plus 4. So we want the left-hand side with the y to have the constant attached to it. So we're going to subtract the 4 on either side. So we have 4y minus 4 is equal to x minus 1 squared. Now, your very last step, remember, is to factor out the a value on the left-hand side so that we do have a coefficient there. So we've got 4 times y minus 1 is equal to x minus 1 squared. Now at this point we do have a couple of different things that we know, right? We can know the vertex, so I'm just going to kind of sketch it over here. We know that it's x is being squared, right? So if x is being squared, it's up, down. That coefficient there is 4, so it's positive. So the opening is going to be up. We know the vertex there is inside opposite sign, so attached to the x, we're going to have the opposite sign being a 1, and then attached to the y, opposite sign being a 1 as well. So from there, we can figure out some other things. We know that we have to have a p-value, right? So you set that coefficient 4 equal to 4p. We divide by that 4, and p tells us the distance between the vertex and the focus and the vertex and the directrix, right? So we know that it's going to be 1 box. We know that the focus has to lie inside, so inside of the parabola, so it's going to be up. But up how many? Up 1 box. Now, your x value stays the same since you're going up. It's a y change, so it's 1 and then 1 plus 1, which is 2. We also know the directrix is in the opposite direction, so it's really going to be 1 box down. Remember, dotted line there. And you're going to be crossing the y-axis, so you have it at y is equal to, you were at 1 and then went down 1, so you're now at 0. Okay, the last part is your axis of symmetry. So the axis of symmetry, remember, is cutting this parabola directly in half through the vertex, and it's always going to be the x value of the vertex if it's obviously facing up or down. So you've got x is equal to, and then 1. All right, so that's the warm-up for today. So that's your parabola. So what I want to do now is kind of get back into the ellipse. So this is the problem that we're going to be doing. So I'll give you a second to write it down. I am going to clear off this board in the meantime. Sorry, I don't have all of my materials here that I do in school, so I only have a couple of different colors, so it's not as, pretty as we're used to, but that's okay, right? We deal with what we have. So I'm just writing out the problem. 9x squared plus 4y squared minus 54x plus 40y plus 37. Okay, so now your very first step, remember, is you do want to rearrange it, x's together and then your y's together. So you've got 9x squared minus 54x. We've got our plus 4y squared plus 40y, and then I'm moving that constant over to the other side, so it's a minus 37. Now, at this point, let me just move the camera back over to what I'm doing over here. there's got to be a better way, right, than just like holding this. Okay, so what I want to do is factor out the a value out of each of them, because remember, you're not allowed to complete the square if you have an a value that's not 1. So we're going to take out that 9. So x squared, 9 into 54, we've got minus 6x. And we have to complete the square now with our b value being 6. So we've got 6 divided by 2, and squaring that, we know that we have plus 9 and then minus 9, right? So what do we do inside? Obviously, opposite signs. Okay, so then we've got the y value as well that has a coefficient that we do need to take out. So we've got that 4. So plus 4 times y squared plus 10y. Doing the same thing with your y values. 10 divided by 2 and squaring it, you've got plus 25 minus 25. And then I'm just going to kind of squeeze in that equals negative 37. Sorry, the board's like much smaller than I have at work, obviously. Okay, so then from there, we have to factor. So we look at the first 3, perfect square trinomial, bringing down that coefficient, 9 times x minus 3 squared. But if you remember, in order to get out of the parentheses, you do have to distribute out that coefficient to that last term over there. So we have 9 times 9, or negative 9, which is negative 81. We then do the same thing for the next perfect square trinomial, bringing down that 4 out in front, y plus 5 squared. Distributing once again, 4 times that negative 25 is negative 100, and then is equal to negative 37. Okay, so what we need to do is move the constants over to the right-hand side. So we're going to go ahead and move that over. So we're going to, plus 81, and then plus 100 over to the right-hand side. Bring this down, 9 times x minus 3 squared plus 4 times y plus 5 squared is equal to, and then adding on the right-hand side, we should have 181, 144. Okay, now the only thing you really need to do next is kind of get it in the correct form. So you notice that your coefficients there are 9 and 4, but we do need to have the right-hand side equal to 1. So what we need to do is, sorry, I was just checking something. What we need to do is divide by that 144 so that we do have some fractional coefficients there. So we're going to divide by 144 on everything. Okay, so that's what we have so far. Let me just move this up so I can get my other piece. And we're going to simplify that, right? So dividing that, we know 9 divided by 144, you think what number goes into both evenly? You're left with 1/16, so 16 is in your denominator, so you've got x minus 3 squared over 16. For the other fraction, you have 4 over 144. When you simplify that part up, we've got 1 out of 36, so 36 is in your denominator there. And then that's equal to 1, okay? So from this, we know a couple of different things. We look at the larger number. The larger number is, or the larger denominator, it's underneath the y components. So if that's the case, we know that the y's have to be longer. So that's going to mean that we're going to have a vertical major axis, so something like that. We can also figure out our a value. So the larger number is a squared. So if a squared equals 36, that means a is equal to 6, right? Plus or minus, because that just tells us direction, but the actual distance is 6 from the center. The other one would be your b squared value. So b squared is 16, and then taking the square root there, we know b is equal to 4, right? So the center, remember, you can find by inside opposite signs. So inside, connected to the x, the opposite sign would be 3. And then the opposite sign for the y would be -5. All right. Now, we have to count how many boxes up and down. Well, if you think about the a value is the longer one. So that's how many you're going to count up. Okay, so I want to go up 6 boxes from this center there. So the x value stays the same, so we still have 3, but my y value, I'm adding 6, so -5 plus 6 is 1. the x value for the one going down, right, the bottom vertex, is the exact same thing, but now we're going down 6. So we have -5 minus 6, and we're at -11. So those are going to be the coordinates of the vertices. Now we have to figure out our focus points, right? So we do that by using the formula c squared equals a squared minus b squared. Remember, there's two different versions of it, but this is the one we're going to use because it's more closely related to the hyperbola one. So the c value is really what we're going to be looking for, and that's that distance between the center and the focus, which we don't have. The a squared comes from the denominator. We've got 36. The b squared comes from the denominator there underneath the x, which is -16. So we've got c squared is equal to 20, and we know that c is the square root of 20, plus or minus, right, obviously, because you're solving, but remember, that just tells you direction. The actual distance is positive. We do have to simplify that out. We know that two numbers that multiply to 20, one being a perfect square, is 4 and 5. So we really have c is equal to 2 rad 5. So we have to think about an approximate value, or how many approximate boxes that would be. And we think about the two perfect squares, that 20 is in between, and it's in between rad 16 and rad 25. So we know that it's approximately 4 boxes and change, right? So we don't really have a coordinate plane here. It's just a rough sketch, so we would count about 4 and a little bit if we were. So we know it's just going to be about here and here. So we need those coordinates, right? So you think about how you've changed. It's a y change, right? So the x stays the same, so it's still 3 comma something. But think about where you were in the for the center. You were at -5, and you went up to rad 5. So it's really -5 plus 2 rad 5. Oh my gosh, it's kind of ugly. So I'll put that here. So focus. We've got 3 comma -5 plus 2 rad 5. And then in the opposite direction, you're going to do the same thing. You're going down. So I'm at 3 comma -5 minus 2 rad 5. 3 -5 minus 2 rad 5. Perfect. Okay, so those are our focus points. Awesome. Okay, so let's jump into the next piece for today, which is really what I was aiming to get to, which would be the scenario type problem. So let me clear my board while you take down what you need. And this time I'm going to give you a couple of different pieces of information, and we're going to be looking for the standard form of the equation of this ellipse. Just cleaning off my board. We know a couple of different things. They tell us that we have focus points at 0, 1, and 4, 1. So what I'm going to do is just roughly sketch that out, because remember, I'm a visual person. I kind of have to see it. Well, that sounds kind of weird. Okay. So at 0, 1, I'm going to place a point. Let me just set this up before I show you. 1, 2, 3, 4. Okay. 0, 1. Label that with an F. And then 4, 1. Label that with an F. All right, so let me show you what I've got. Save this so far. So we know our focus points, right? And because our focus points lie horizontally, we know something about the ellipse itself. We know the generic form of it. So we know that let me write this out, x minus h squared over y minus k squared over equals 1. Okay, so we know that our a squared value, the larger one, has to be located underneath our x, since the focus points lie horizontally. So our major axis is a horizontal major axis. So we've got a squared underneath the x, and then b squared underneath your y. So from here we can find a couple of pieces of information. We can find the center. We know that the center has to be directly in the middle of these two focus points. So in the center we've got 2, 1, and that's our center. All right, so we can plug those into the equation as the opposite sign. So let's do that. We've got x minus 2 squared, y minus 1 squared, and then we need our denominators. So we need to find our A, B, and C values. So if you remember, we know our C value. The C value is the distance from the focus and the center, and that's this right here, right? So that distance. That distance, if you count, is 1, 2 boxes. So let's think about our formula. The formula is C squared is equal to A squared minus B squared, and if we know that C is 2 boxes, we can plug into C squared. Well, C squared we know is 4. We also can know a couple of different things, right? We know C squared is 4, but how can you figure out any other values? So if you think back to the original question, it said that the major axis length is 6. Well, if we know that the major axis length is 6, and the major axis, remember, is 2a, so that means that a has to be half of that length, which is 3. So a must be 3. So we're going to plug that in. We've got a squared, which is 9, and then that's minus b squared. So we're just going to solve out for our b squared here, subtracting the 9. We've got negative 5 is negative b squared, dividing out that negative 1. And we know that 5 is equal to b squared. And we really don't need to solve for b because the equation itself is b squared, right? So if b squared is 5, we're going to plug that in here. And then we already said that the a squared value was 9. And there you go. That would be the equation of that ellipse. All right, let's do one more. I'm going to just put that there for you while I clean off the board. Go ahead. So this time we have 2 coordinates again at different locations. So we just got to rough sketch this out. 1, 2, 1, 2, 1, 2, 3, 4. Okay. Negative 2, 2. Label that with an F, and then 4, 2, label that with an F. Okay. So this time we know that we have focus points at negative 2, 2 and at 4, 2. So it's going to look something like that, right? And what we can do is we can find the center. Now remember, the center has to be directly in between those two. So what you can do is count the number of boxes. We know it's 1, 2, 3, 4, 5, 6 boxes to the other focus, which means it has to be directly in the middle, which would be 3. 1, 2, 3. So we're going to be about here, and I'm going to label that as the center. So that's at the coordinate 1, 2. We also know the generic form of this ellipse because since the focus points lie horizontally, once again, your a squared value has to be underneath your x's. So let me just do that out here. That's a square. Okay, so let's plug in for the center. We know that it's x minus 1 squared. Remember, inside opposite side. We've got the y minus 2 squared, and then that's equal to 1. So we need to find a couple of different things. So let's just write out the formula for our c again. A squared minus b squared. Okay, so remember, c is the distance from the focus to the center. So if you look at this distance right here, right, you have to count the number of boxes. And we already kind of said that it was 3, right? So 1, 2, 3 to double check. So c is equal to 3. That means c squared is 9. So based off that, we can plug in some things, right? We, once again, remember that, I'm just going to go back to the question. The major axis length is 10, so the entire length across is 10, which means that half of that length is 5. So going back here, our a value is 5. So we have 25 for our a squared, and then minus b squared. Subtracting that out. Here we go, negative 16 is negative b squared, and then just getting b squared by itself, b squared is 16. So b squared is 16, so we're going to plug that into our equation. So that's 16. And then we already said that a was 5, so that meant that a squared was 25. And there we go. So that's it for today. I hope you were able to, understand kind of what we did. I know it's like a little difficult with the situation that we're given, but we're going to try our hardest. Please email me any questions that you may have. I'll be able to answer them. I'm going to post your assignment coming up next, so stay tuned.